Hi everybody, today I start second lecture of the statistic and I continue the last lecture. It is about population and sample. As you remember, the population is the entire group of individuals that we want information about this. For example, a student of the university, sample a part of the population that we actually examine in order to get information. As you see here in the photo from the population, we can make sampling to form the sample. It is very important, and also sample is the representative of the population, or we can say it is the influence to the population. And as I mentioned example, for example, we can measure blood pressure of the healthy people. Can be measurement must be made of different populations. Very important. One of the best example, for example, if you see the sample and the population, for example, if you have a population medical student, okay, or student, we can make a sample from, for example, questionnaire filled in by a group of the medical student. We give a form for some of student or blood pressure of the woman, and we say blood pressure of the 20 healthy women, which is, as you see, the sample is the part of the population. Last week we studied about this, the type of the variable. It is a categorical variable, or we can say continuous. For example, if you see, we have an example in the gender here, and as you see the chart, rate frequency of the categorical variable between the female and the gender, and in the population, distribution of the variable in the population is very important. For example, in this example, we see we have a male and a female. We have a 20 male and 67 female, and we can find the percent and the valid percent, and also, and if we can show in the chart also. For the population and sample, we can find for the sample we can find the mean. Mean can be equal sum of the sample divide the number of sample, or we can find the standard deviation or median. We studied last lecture, and also in the population we can find the mean, but with the micro with is unknown, or a standard deviation with a sigma sign is unknown, and the median also we can, as you see here from the both of them, the type of the finding is different, because as you know, for the sample it is a representative of the population, and we select it from the population, and it is very easy to find the mean and standard deviation and the median. The basic of the probability theory. The first things about probability, we study about randomness and random experiment. Okay, we have many examples. For example, if we have a rolling disc, okay, we have a 6 possibility, or then we can say randomness is the outcome is not determined uniquely by the considered condition. For example, tossing a coin, we have a possibility to coin, it is 1 to half, 1 to 2, it is a half. Rolling a disc, every possibility from the 6th number, it is the 1 to 6. Measure also water level in the river every month, or something other. We have many examples. And every experiment has a more something in initiate large number of the outcomes. It's very important. It depends what we want to do, make an outcome. For example, if we say even number, randomness, for example, 1 over 6 for 2, 1 over 6 for 4, 1 over 6 for the 6. Okay? And it's very important, for every even number, we can have a this number. Then the result of the experiment is very important. One of the results is the elementary event, the possible outcome of an experiment. For example, we want to know what is the possibility of the rolling disk, composite event. It can be divided into the elementary event, and the certain event always occurs, and impossible event never occur. It's very important. We can, for example, I can show all of them here. We have a rolling disk, the all possibility 1 to 6, composite events. I can show all of them here. It is divided into the elementary event. For example, odd number, even number, bigger than 4, or the result of certain event. It is because we can see one of the possibility for this number. It is a certain. What is the impossible event? For example, 7, number 7, because in the disk we don't have a number 7. In this case, we can say it is impossible because we don't have a 7 number. Now I explain operation with the event, the complementary event. For example, in these photos, as you see here, if we have an event A, is the event minus A or opposite A with line, which occur wherever A is the phase. It's very important. For example, if we have a E1, 1, 2, 3, 4, okay, E1 with the line will be 2, 4, 6. The sum of the two events A and the B must be, okay, if the A or B can be accurate. For example, if we have A 134, 135, and E2 is the 246, it will be all of them. But if we have E1, it is a 135, and E3 is the 15. In this situation, we can say, because 5 we can see in both times, we can write just 15, and will be all of them 1, 3, 5, 6. The product of two events AB is event AB which occur when and B, A and B can be occur. For example, if you see 1, 3, 5 and 2, 6, the product of this one is 0. But if we have a 1, 3, 5 and 1, 5, 6, because the 5 can be in the both groups, we can see in this case. I can show you, for example, in here, this area, it is a product of A and B. And here we can see A plus B will be all of the possibility can be shown with A and plus B. For example, if we have in the A 1, 2, 3, if we write A 1, 2, 3, 3 number, 4, 5, 6, it will be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. If we have here 1, 2, 3, 4, 5, 6, in this case our product B will be just number 3. Now we go to the concept of the probability and relative frequency approximates probability. It's very easy. For example, if we have a repeat experiment for the car time, okay, the repeat of experiment for n time, okay, every time we can find the car. For example, I start with the rolling disk. From the 0, start 1, 2, and go, for example, n time. Okay, in this case, as you see here, start rolling n times of the disk. In the large number of the experiment with the rolling of disk, a event is observed to occur k time. In this case, we can say is always is more than 0 and is smaller than n or equal smaller than n can be k. Now, if we divide both of the group for n, in this case will be k divide n equal to 1 and 0. In this case, we can say it is relative frequency. Relative frequency, it is between the equal bigger than 0 equal smaller than 1. In the last here, this k it is the frequency. It shows how many times we can repeat the experiment, and it shows relative frequency. Okay, if n is very big, for example, I repeat 1 million times or 10,000 times, in this case, kn will be very small number, because if this number is called probability of the occurrence of the event A. And for this event, we can write in this formula, it is the PA is bigger than equal 0 and is smaller equal than 1. It's very important. For example, I show one example about coin. Okay? For example, n is 10 times, 100 times, 1,000 times. Okay? K, the first one is the frequency 4 times, 54 and 496. And if I find the relative frequency 0.4, 0.54, 0.496, as you see here, in this case, if your number are increasing, the possibility of a percentage will be very high. The probability of the event A is the number approximated by the sequence of the relative frequency when repeating the experiment many times. Okay, and probability fact also probability measure uncertainty, because we don't know really what's happened, how many percent, as how many times. Okay, usually we cannot say 100% it can be happen, but we can say how's the probability. And any probability is the number between the 0 and 1. Just we have a possibility between the 0 and 1. And all possibility outcome together must be probability 1. And some of them must be 1. Okay? And the probability of the complementary event R will be usually 1 minus PA. What we studied last page. If you say we can show when the number of n is very big, we can say we can convert k plus n for the PA. Now we find the PA. PA equal F per T in the formula. What is the formula? In this formula, we can see the number of the favorable outcome to the total number of the outcomes. Okay, the probability is the classic. If all elementary events are equal probable, then for example, for the coin, if we for every rolling, for example, coin or rolling disk, possibility for the coin is the 1.2, 1 over 2 or half, and 1 over 6 for the disk. Always, for every time, we can use this formula. Rolling of disk, as you see here, rolling of disk, what's the probability that the disk for sure 5, always P5, always will be 1 over 6. And what is the probability that the disk shows an odd number 1, 3, 5, in this case, 3 number per 6 will be half. Okay? Now we go to the probability and the odds. What is the odds? The odds are a way of representing probability, especially familiar for betting. For example, the odd is the ratio of the probability that event of interest occur to the probability that not happen. We know the probability, some of the probability will be 1. For example, if we have as you see here, the interest probability is here. The sum will be 1. In this case, not, it will be 1 minus p. Or we can say from this number, odds can be number of the times the event occurs. It also we can show by the p. Number of the times the event does not occur, it is 1 minus p, because we know the sum of the occur event and non-occur will be 1. For example, this disc rolling, the probability of the rolling 3 is 1 over 6. Okay, the odd that is singles through a disc will be produced as 3r 1 to 5 is 1 over 5. In the case of rare event, the odd and the probability are similar. For example, if we have an odd ratio is used to compare odd into 2 independent groups. For example, if I have a group 1 and a group 2. Group 1, we have event occurred, for example, in the clinic is the ill patients, and also B is the non-ill patient, but it is the risk factor of the present. And the group B is the C is the ill patient, and the D is not ill. Okay, if we find odd ratio, it will be ratio between the odds of the group 1 and group 2. For group 1, it is R per B, Y, because we know odds equal P minus 1 minus P. Because there's a R is the P here is the event. Interest, it is A, and 1 minus P, it is a B. Okay? Again, odd will be P minus 1, P over minus P equal C per D. Now the odd ratio, it is the odd ratio between both groups, and if we divide here, we can find this ratio. The odd ratio greater than 1 indicate that the condition of the even is more likely to occur in the first group. And if the odd ratio is equal to 1, the possibility is the same for both groups. And if it is the less than 1, it is indicate that the condition of the event is less likely to occur in the first group. As you see here, I write example for you with the same formula. Now, for example, I changed formula. Okay, as you see the last page. Okay, the same formula. I write example. We have a high fever patient, 141, which has eczema also. Okay. And non-eczema with high fever is 928. But eczema with no high fever is 420. And no eczema, no high fever, it is this number. Now we say odd ratio. We can find 141 divide 420. Again, 928 divide 13525, and if you find this ratio altogether will be 4.89. Having eczema, the odd is 4.89 times higher for having a high fever compared to the children without eczema. Also, we can use the very nice online site for the calculation. It is very important. www.medcalc.org/calc. Okay, we can find with this formula for the calculation of the group, we can show A, C, and B and D. We can find the odd ratio is very important. Or we can calculate the odd ratio using RStudio. And next lectures I will explain about the software of our program and how we can do the example data in this one. Just I showed the result, how is it possible for this result. As you see now, 95% of confidence interval, it can be here, and also sample estimate in here. And now we go to the random variable. Random variable or probability distribution. A random variable is the variable whose value is the numerical outcome of the random phenomenon. Okay, mathematically it is a function that assign numbers to each of the experiment outcome. For example, if we have a x and y, in this situation it can be belong to the R. R is the set of the real number. I give a good example. The experiment of the rolling disc. In the rolling disc, we have this number 1 to 6, okay? And now we have X, the number of shows it on the disc, okay? Which we wait for the first person entering the lecture hall immediately. Measure her blood pressure. The blood pressure is random variable for each of them. Now I give other example. For example, discrete random variable. For example, we can have a x specific value. For example, the probability distribution of the x lists the value of the x and their probability. For example, values are x can be x1, 2, 3, and a number. Probability were p1, p2, p3, p5. Like rolling this 1 to 6. And for all of them, we have a possibility 1 over 6 for each of them. Then, if the sum of this probability will be 1, if we have a 1 over 6 plus 1 over 6 plus rolling this plus 1 over 6 plus 1 over 6 plus 1 over 6 will be 1. As you see here, what I showed you in here, the probability of rolling disc for each possibility or coin will be half. As you see in the table, we can show in the table for the coin we have a 2 possibility, 1 and 2. For the disc we have a 6 possibility and each possibility has 1 over 6. There are also uniform discrete distribution, which all pi will be equal. Approximation of the theoretical distribution with the relative frequency. If we do not know the theoretical probability, we have to approximate them by relative frequency. We studied about relative frequency with the k power per n, which can be bigger than 0, equal or smaller than or equal smaller than 1. Thus, in the coin experiment, the theoretical contribution of the variable is the p1 is half and p2 is half, and all possibilities, sum of the p is equal 1. Okay, and from 100 repetition, we can get the car 52 head and 48 tires. Now we can find the relative frequency is very important. It is 0.52. Approximate equal to 0.5, and the relative frequency K2 per 100 is n is 0.48, is approximately half, and some of them will be again 1. If we can say 0.48 plus 0.52 will be 1 again, then if the number of the, it is in this case very important we know the sum of this relative frequency also can be in the equal to 1. Other, for example of rolling two disks is very important. Not uniform discrete distribution. For example, if we have a variable x and some of the two numbers shows in the two disks, for example, in the one disk, px is equal, x1 equals 0 and x will be impossible. And for the second, x2, x equal 2 is equal 1 over 636. The only favorable event is 1 per 1. Then the number of those possible events is 36. I can show here in this table. If you see here, all possibility we can see in the x can be start from the 1 to 7, and here also in this case, if you see it, if x is the equal 7, the increase the number of the event in this case. And the expect value inform about what expect is an experiment in the long run after many trial. For example, in most of the case, we know about that some of the event, okay, can be equal 1, and it's very important. For example, if we write about experiment, we can show it with the e of x equal sum of the variable I equal 1, and in the end pi in the xi. And in the distribution function, if we let the x be a random variable and let x be real number between the minus infinite and the positive infinite, and examine the probability of the x, big X is smaller than smaller x, this probability function of x is the cumulative distribution function of the x and denoted by the x fx. For example, this example, if we have a rolling disk, every possibility is the 0 point we see here, and increase the possibility, rolling possibility between these two distributions. And if we have a rolling two disk, as you see here in the fx, the between them will be increased. And as you see here, you start more differentiation here and rolling with two disks. And as you see here, and the function almost like would be more soft compared for one disk. For example, for one disk, okay, if we see, we can find EX for each of them, possibility, probability, multiply the number, and probability plus multiply number, probability multiply number, probability multiply number, and in the end we can find the number. So average, we get a 3.4, for example, for the rolling of this. But example, when the disk is not fair, for example, the through have the following probability. In this case, for example, for 1 is 1 over 12, 2 is 1 over 6, 3 1 over 6, 4 is 1 over 6, 5 1 over 6, and 6 is 1 over 4. In this case, if we put the same situation, the number would be 3.91. In average, you get 3.91. And the variance is the measure of the spread for the distribution of the random variable that determines the degree of the which that values of the random variable differ from the expected value calculation. For example, we know variance equal a standard deviation power 2, or we can say in this case formula, it shows the number of the event, sum of the number of events for the probability multiply x minus mean power 2. And if we see the variance, we can calculate variance with the formula. It's very important. If you see the probability, multiply, as you see, 1 minus 3.5 power 2, and again we continue this formula and we can find the variance with 17.5. If we make the radical of this point, will be a standard deviation. Then standard deviation will be 4.183. And some spatial discrete distribution I will start in the next lecture about this topic. I hope it will be good. And see you in next lecture about statistic, and I hope you will be fine and have a good time.